Yeah, he's going to explain the whole thing to us. Chemical bonding, chapter 12. Fun, fun, fun. We're going to attempt to cover the first 3 sections today.
This is the only part last year that did not like is chemical bonds.
And I forgot to edit the slides, so I'm sorry we've got all these animations. So, questions to consider. What do we mean by the term chemical bond? And we're not answering these questions right now, we're just asking them. Why do atoms bond with each other to form compounds in the first place? How do they do that? Oh, we forgot a question. Why should we care? Okay, a chemical bond. We can define a chemical bond, but there's no simple way to do this that's complete. So, atoms are held together in groups by forces. Okay, so there are forces that hold them together, and they make them function as a unit. And so in our little imaginary chemistry world, we can, make these into different things. We can imagine those as 2 little blue styrofoam balls superglued to a big red styrofoam ball. And the force is the glue, and they're stuck together, and they're not going to come apart. So they're functioning as a unit. It really has to do with energy levels. And a bond will form if the energy of that unit, this really big word, aggregate, if the molecule has lower energy than the separated atoms, then that will form. So everything comes down to energy. And then if you want to break that bond, it's going to require energy. And that kind of makes sense. If you've got things that are stuck together, you can think of this as magnets, perhaps. And you've got these, one large magnetic ball and these 2 smaller ones, and they stick to it. To take those little balls off, you're going to have to exert some energy to pull them off, right? And they're going to stick together because that's a favorable energy state.
What does that mean, the energy of the aggregate is lower?
If the energy, I hate these. It won't let me go back. Fine. If the energy of the molecule, the aggregate is the molecule, the things all stuck together. I really should get rid of that word because nobody knows what it means. I don't even use that word much. If the energy of the thing together is lower, then it will form a molecule. If the energy of it is higher, it's not going to form a molecule. It's a little bit like, getting a deal at Disneyland or someplace, And, well, if we have this, getting a group discount, okay, so this is a good thing. If it costs more to go as a group, we're going to go as individuals, right? Duh. I mean, who's going to pay more to just say I'm part of a group when you still get into Disneyland? That doesn't make any sense. But if it's cheaper, then even people that you don't even know are going to be willing to be part of your group because it's going to be cheaper to get in, right? So that's a little bit how it is. There's different kinds of bonding. Ionic bonding is one kind, and we learned from our study of nomenclature that ionic bonds form between metals and nonmetals. So an ionic compound has a metal and a nonmetal. And in ionic bonding, electrons are transferred. They're transferred from the metal to the nonmetal. And so here we have an illustration. So here we have the metal, and the metal is going to give an electron to the nonmetal. When it loses that electron, it has a positive charge. And when the nonmetal gains an electron, it has a negative charge. And we learned to predict those charges from the periodic table, but without really understanding why they did that. So nonmetals form negative ions. Well, now we have a positive and a negative. Opposites attract, and so they're attracted to each other. They transferred an electron, and now they have opposite charges, and the attraction of those charges is the ionic bond. Just interrupt me if you have questions. And then there's covalent bonding. Let's look at that word, covalent. Co means sharing. And valent refers to valence electrons. A covalent bond results when the electrons are shared by nuclei. The ionic bond, the metal gave an electron or more to a nonmetal. And then there's opposite charges that attract. Here, there's sharing of electrons. So here we have a hydrogen atom with one electron, and here we have another hydrogen atom with one electron. And they're apart from each other, and they've got no interaction. But when they get close together, they will each share one of those, their only electron. They'll each share their electron with the other. And now, because of that sharing, they have a bond between them, and that holds them together. I'm just debating whether to go into the analogy of people and their children. We'll go there anyway. So you get a man and a woman, and they have a child together, or maybe they have 6 children together. And those children, at least, they should bind them together, because we're in this together, we're caring for these children. That analogy doesn't work so great, because sometimes the children drive the parents apart, right? That's not what's supposed to happen, though. So we're not going to go there. Covalent is sharing electrons. Then there's 2 kinds of covalent bonds. Sometimes the atoms share the electrons equally, and sometimes they don't share equally. This is like, the big brother and the little brother sharing the cookie. And the little brother gets the little part of the cookie, and the big brother gets the big part, right? They're sharing. I shared with him, gave him this little crumb, right? But it wasn't equal. Okay, so sometimes atoms share equally, and sometimes they share unequally. So in a polar covalent bond, we have unequal sharing. And this is due to the fact that one of the atoms in the bond attracts the electrons more than the other atom. And that's going to result in a partial charge separation. So one end of this bond is going to be a little bit negative, and the other is going to be a little bit positive. It's a partial separation. It's not like an ionic bond, where you have a +1 and a -1 charge. This might be a plus 0.33 and a negative 0.33. So it's a partial charge, but there's a little bit of charge separation. Okay? Oh, good, there's a picture. It's kind of a small picture. So here is hydrogen and fluorine. Fluorine is much more attractive to the electrons than hydrogen is. And so when these guys share the electrons, they don't share very equally. The electrons are hogged by fluorine. He hogs the electrons. So this is like the big brother. He's taking more of the cookie than he should. And so we get a lopsided charge density. So we get the electrons spending more time over here and less time over here. And we use these little symbols. This is the Greek lowercase d. It's a delta, delta plus and delta minus. And so this end is a little bit positive and that end is a little bit negative. But it's not an ionic bond. And so I do have an analogy for this. So you've got 2 little boys, and they're really good friends, playing in the neighborhood. Maybe they even live next door to each other. But they come from, let's start out saying they come, never mind. Okay, so their houses, though, are really different. Okay, so one house, they don't even have an internet connection. They've got an old VCR and some Thomas the Tank Engine videos. And if you're hungry, Mom will make you a peanut butter sandwich. They don't even have any jelly. And a cup of water. No ice maker, so it's just tap water out of the tap. Okay? Nice mom and everything, but just not so fun for kids to be over there. No game systems or anything. Next door at the other kid's house, so that was Hydrogen's house. And next door at Fluorine's house, they've got the big screen plasma TV. They've got the satellite with all the channels. They've got every gaming system known. If you're hungry, Mom will order pizza delivered, and they actually have a soda fountain installed in their kitchen. You just go up and get Pepsi anytime you want, right? Where are those 2 little boys going to spend more time? At H's house or F's house? They're going to be over at F's house almost all the time. It's more attractive to them. Fluorine is more attractive to electrons than hydrogen is. And so when they share electrons, when their electrons play with each other, they spend more time next to the fluorine atom than they do at the hydrogen atom. And so that ends up making it lopsided. Because hydrogen has 1 proton and 1 electron. Fluorine has 9 protons and 9 electrons. And so if hydrogen's electron comes to visit at fluorine, that's going to cause it to be a little bit more negative than before.
Is it less stable?
It actually becomes more stable because they're sharing electrons. We skipped chapter 11, where we would have talked about electron configuration and all kinds of stuff. And I skipped that because, for one thing, it's not in the course outline, and it's not something that we just really need to study yet. We can explain this stuff a lot better if we do study that, but we'll be fine. We'll be just fine. So, types of bonds. So what do we mean by a chemical bond? Can you throw out some ideas we talked about? They don't have to be complete sentences or even fancy words or anything. What is a chemical? A marriage between 2 atoms, okay? So it's something that holds 2 atoms together, right? Is a chemical bond. Why do they bond with each other? They're attracted to each other. Yeah. It really comes down to energy. They form that bond because when they form the bond, it's lower energy. Okay, so you have this bunch of strangers at Disneyland, and they hear that there's this discount, for a group. If you've got 10 people or more in your group, then you pay less money to get in. And so there's these people outside the gate. It's like, hey, do you want to be in my group? Hey, come on, be in my group. And so you get a bunch of strangers be in a group. Why? To save money. Atoms bond together to save energy. Okay, so that's why they do it. How do they do it? We talked about 2 ways. Sharing or transferring. So covalent is sharing. Like co-sleeping. Covalent, co-sharing. Sharing. Yeah, whatever. Sharing electrons. And ionic bonds are transferring electrons. So those are the 2 ways in which they do that.